on chapter 1, so we'll finish chapter 1. Today's Tuesday, so we will review Thursday, and then there will be your first test will be next Tuesday. So you have the option of whether or not you want to come to campus to take your test or take it online. If you come to campus, we would take it in room 114. You come in the main administration building into the front door and go past the office and take a right. And you go all the way down the hall. And before you get to the side doors that lead to the outside, you take a left down just a little small hallway and you go past my office and into classroom 114. So that would be where we would take our test if you came to campus to take it. So you have the option to take it online. It will be in Math Lab and it will be monitored through HonorLock. So I will be posting, if I may have already posted those instructions, but if I haven't, I will post a video that shows you how to take an online exam using HonorLock. And also, I will make you a practice, just a one question practice quiz in Math Lab to give you to take with HonorLock so that you won't have stress of making sure everything works correctly. So just follow the instructions that they give you in the video. I would write them down. Follow the instructions they give you in the video, and then after our class Thursday, take your practice quiz and make sure that you don't have any issues with that. So if you're going to come to campus, you would just come at normal time. So it would be, like 1 o'clock to 2:15. I would be in the classroom. So if you were a little late or whatever, I would be in that classroom with the students that are taking it. So you would just come on in. But yes, about same time. In fact, the one online is going to be during class time as well. I'll probably add about 15 minutes just in case you have technical issues or anything like that. Some of you can't come to campus, and I understand that. That's why you have the option to take it online. But if you want to come to campus, I wanted to give you that opportunity as well. Yes, I'm on the Thomasville campus. So that's where we would be, Thomasville campus. Of course, if you're from another area, you wouldn't be able to come to campus to take it because it would be too far to drive. But if you're close, then you might feel more comfortable doing that. But I do need to poll you and ask you if you plan to take the test online or on campus now. So if you could just either unmute yourself and tell me or type into the chat box whether you want to take it on campus or online, that would be great. Okay, so I see most people are saying online, but don't feel like you can't come to campus because if only one student wants to take it on campus, I'm going to be here anyway, so it would be fine. If you tell me you want to take it on campus and you change your mind, that would be fine too. You just need to let me know, prior to the test that day. So you can plan on taking it online and decide you want to take it on campus or vice versa, but you just would need to let me know prior to class that time. Because if you're going to take it on campus, I will need, to make my paper copies. And again, you don't have to decide today. Just tell me what your plans are, and if they change, then that would be fine too. Another thing I've noticed is some people are coming and opening up the session, the online session, and then leaving their computer running so that when we're done, there's people still online that really weren't watching the video in the beginning. So on looking at the grades, I see most of you are doing a good job, But if you are just opening up the session and leaving and not paying attention or not using the materials, I would just prefer that you didn't use the space in the online chat. I would just prefer you watch the videos and do your assignments. Um, Again, attendance is not being counted against you, but if you aren't doing well in the class, I am going to send I'm going to send information to the Student Services Early Alert System, and they will be contacting you. So if you are attending class and you're having problems, then we need to get you some extra help. The ones that are not attending class, of course, that's going to be the first thing they say is, why aren't you attending the classes? So sometime during this conference, and I'm not going to tell you when, sometime during the conference, I'm going to call roll. I've already gotten the roll for the initial attendance. So sometime during the session, I will call roll, and you will be required to either answer me or type into the chat box that you are here. That way, if someone's just opening up the session and leaving, then I will know that as well. So sometime during the session, expect to have a roll call. I'm going to share my screen with you and pick up where we left off the other day. So I did adjust your due date for 1.7 since we didn't finish the quadratic formula. And that's what we will do today, is finish the quadratic formula and then do our last section on inequalities. So when we're looking at a quadratic equation, this equation right here that I'm putting a box around, that's called standard form of a quadratic equation. So that's standard form. And the quadratic formula comes from using the coefficients in front or the constant at the end. So the a is always in front of the x squared, the b is in front of the x, and the c is the constant that's by itself. So regardless of what order these come in the problem, you need to rearrange them in that order and pick out your a, b, and c that goes into the quadratic formula. So using the quadratic formula, this one is in the correct form. It's equal to 0, and everything is in decreasing degree order. So I would just say A is 1, B is -2, and C is 4. Then I'm going to substitute to solve for X into the quadratic formula. After I have picked out my coefficients, my A, B, and C, then I'm just going to substitute them in. So when this says negative B, I think of that as opposite of B. So if my B is negative here, then I'm going to change the sign. Because the opposite of B, or negative B, is the negative of -2. So that's going to change to a +2. And now we do -2, and you must put this in parentheses if you're going to use your calculator to plug this in. You have to put that -2 in parentheses before you square it, because that's going to make that a +4. So that's what I have. Now, I like to take that radical part right there, and I like to go over to the side and simplify that and then come back to my equation. So that's what I'm going to do. So I've got -2 squared, which is 4, minus 4 times 1 times 4 is 16. So that's going to give me the square root of -12. And if you remember, a negative in the radical comes out as I. That's an imaginary number. So essentially, we're breaking this down into the square root of -1 times the square root of 12. So we just bring that -1 as I. And then remember how we break down the square root of 12? We used a factor tree, or we just said, well, I know that 4 is a perfect square. So I'm going to break it down into the square root of 4 times the square root of 3, and then that gives me 2 times the square root of 3. But I have an I here, so I write 2I times the square root of 3. I put the I in between the rational part and the irrational part. So this just breaks down the square root of 12. You can also break it down using a factor tree. So what I end up with is x equals 2 plus or minus this plus or minus 2I times the square root of 3 over 2. And then remember in the last section when we were simplifying these, we would break them into two fractions, or we would factor out the 2. Either way. Just make sure that denominator divides into both of those terms. So 2 divided by 2 is 1. And then 2 divided by 2 is 1 again. So I just have 1I, or just I square root of 3. So all I did was just simplify those two fractions. And so you would need to write this as 1 plus I square root of 3, because I believe MathLab wants you to separate those into two answers, and 1 minus I times the square root of 3. So the reason we would use the quadratic formula in this problem is that's not going to be factorable by methods that we know how to factor. So you're not going to be able to factor that. You could complete the square on that if you prefer. Most people learn the quadratic formula and just prefer to use it rather than completing the square. So copy down your quadratic formula, and then I want to ask you to work the next question. Now, first rearrange it in the proper order before you pick out your A, B, and C. So I would like for you to try, and if anyone gets finished with it and would like to share your answer, that would be good too. So I'm going to help you get started here, and then I'm going to let you finish. But this needs to be in standard form before we plug into the quadratic formula. So the first thing we need to do is make this thing equal to 0. So we're going to subtract the 12x from both sides. And I'm putting it in the middle because that would be decreasing order of degree. So we want to make it in the right order. So when I subtract from both sides, I get 0. So I can't combine the minus 12x with either one of these. Those are not like terms, so I just bring it down. And I brought the 4x squared down first, then the x term, then the constant. Now you're ready to plug into your quadratic formula. Make sure that whole numerator goes over that denominator, not just part of it. So a common mistake is to not put a negative in front of 12 if you try to pick the before you get it in standard form. It's going to look like that 12x is positive, but when you move it over by subtraction, it's negative. So be sure that you make sure that negative is there on the 12. I don't know why I can't seem to write that negative there. Does anybody happen to have the answer yet? Yes, I believe it would be. Now I'm going to finish it up, but I believe that's the correct answer because your discriminant or the radical part, I haven't explained the word discriminant yet, but the part under the radical should be 0. So that should be correct. So the radical part, I like to do this over to the side because it keeps me from making errors and bringing all that down. So that second part right there is just 0. So if you're adding or subtracting 0, all you're going to get is the 12/8. And you can go ahead and put plus or minus 0, but it's still, that's going to go away. So you're only going to have one answer for this one. And that would reduce to 4 divided into 12 and 8 would be 3/2, just like Ethan had said. So that is correct because the discriminant or the radical part goes to 0. So now I'm going to introduce you to the word I keep saying, the discriminant. Anybody have any questions on that before I move off of this slide? Very good. I appreciate the participation. Okay, no questions. So I'm going to move to the next slide. This kind of explains how the discriminant can tell us a lot about a quadratic equation. It will tell us the number of roots that we'll get or the solutions, and it will also tell us the type of solutions or roots that we will get. And the word I'm using for solution, which we will be talking about more in the next chapter, the word I'm using is roots. When we graph these, we will see that the roots are the x-intercepts or where the graph crosses the x-axis. So the solutions to these quadratic equations are very important to us when we start our graphing. So the discriminant is just the part under the radical. If the discriminant is greater than 0, that means that it's positive. Okay, so if the discriminant is positive, then you're going to get 2 real solutions. Could be radicals, but they will be real. They won't have an I. They won't be imaginary. If the discriminant or what's under the radical turns out to be a negative number or less than 0, then you're going to get 2 imaginary or complex solutions. So you're going to have an I in your answer. And then, so we've seen the second 2 cases already. And then if b squared minus 4ac under the radical, if that happens to be 0, then you're just going to get this one answer. It's just going to be the negative b over 2a part. It's going to be your answer for that. It will only be one solution. and it will be one real solution, not an imaginary solution. All right, so if we take what we know about this slide, and of course, if you're trying to copy this down, you can go back to the slide. It's in your modules under the PowerPoint. I think it says PowerPoint Fall 19, but I've used this same PowerPoint for a couple of years, so it's the same one. So it says for each equation, state the value of the discriminant and the number of roots. So in this case, we wouldn't need to solve the quadratic formula. All we're interested in is the number of real roots that we get. Okay, so the number of real roots would mean any roots that are not imaginary. So watch your wording in MATLAB, because they might ask you for how many solutions and what type, or they might ask you how many real roots there are or how many real solutions. And if they ask that, then, well, let's just do it. This is A is 5, B is -7, and C is 9. So I'm going to just do the discriminant part, B squared minus 4AC. So I'm going to have -7 squared. Just remember, all it's asking for is how many real roots. So we're going to find out how many real roots are here. So this is -131. And all I really needed to know is if this discriminant is negative. So since the discriminant is negative, then we have no real roots. Because in the last screen, we said, well, if that was 0, then we had 2 imaginary solutions. So there are no real solutions. That's all it's asking. How many real solutions? If it's negative, there are none. Okay, so we know we have 2 imaginary. Which automatically implies we have no real roots. And that's important, because if we're graphing this and we need to know where the x-intercepts are, there wouldn't be any x-intercepts, because this quadratic equation might look like this. And the reason that there are no real solutions or real roots is because this graph is never going to cross the x-axis. So it has solutions, but not in the real number system. So it has solutions that are imaginary. So remember, these are already in standard form. They're already in decreasing order of degree, and they're equal to 0. So we can just pick our A, B, and C straight from the equation. So this is going to be 144 minus 144, which is 0. So in this case, we're going to get one real solution or one real root. And we use those words, roots, solutions, and zeros also is another terminology. Zeros, roots, or solutions all mean the same thing. So anytime you see solution, root, or a 0, those are going to be the same thing. We're going to use those terms interchangeably. And so that's it for that. So you're just plugging into the quadratic formula or you're determining the roots. So we've done 2 examples where we actually plugged in. But remember, I like to, when we actually solve it, it makes things, you don't have to do this, but it makes things a lot easier to go off to the side and do your radical part and then come back and simplify. So when we come back next time, we'll review. If you need extra help or you need another example of the quadratic formula, you can just let me know.
Miss Rachel, what determines the amount of real roots?
Hang on a second. I didn't realize that I didn't have my speakers turned up real good. Could you repeat that for me again?
Sure. What determines the amount of real roots?
Okay, what determines how many you have?
Yes, ma'am.
This slide right here. If the discriminant, which is the part that's under the radical, this part right here, b squared minus 4ac, if that's a positive number, then you're going to have 2 real solutions or 2 real roots. If that number is negative, you're going to have 0 or no real solutions or roots because there will be the roots will be imaginary. Kind of like in that first example. I'm going to back up. That first example, you see we got a negative number under the radical, that part b squared minus 4ac. It was negative. So that meant that both of our solutions were going to have an I in them. They were going to be imaginary.
Yes, ma'am. Thank you.
You're welcome. And then if you get a 0, then you know you're only going to get that one solution. It's going to be whatever that number turns out to be because the plus or minus part is going to be 0. Okay. So that b squared minus 4ac determines the number of roots you're going to get and whether or not they are real or not. Any other questions before I go to this last section? Anybody at all? Did that answer that question for everyone? I'm back on the screen so I can actually see your, okay, good. I can see your typing. Thank you, Victoria, for translating there. I didn't realize my speaker wasn't turned up very high. I was watching a video earlier and it was so loud that I turned the volume down. Okay, so the last part, and if you'll look at this chapter 1 material, it's kind of reviewing a lot of the algebra skills that you're going to need for the rest of the chapter. So all of these topics in chapter 1 are just sort of reviewing what we need to know for the rest of the chapter. So please really go back over this material. If you need to watch the videos, they're my videos, so it's going to be the same as if I'm teaching you. It's just in recorded form. So they're in your modules as well, all of the videos for each section. And so watch those if you need to go back over any of this. So in chapter 8, section 8, pardon me, we're looking at inequalities. So we're going to look at simple inequalities and we're going to look at compound inequalities and we're going to review how to do interval notation. Now, if you've never seen interval notation, I'm going to go over it like you've never seen it before. It's pretty easy to use interval notation. And if you're going to ever take a calculus course, you're going to use interval notation instead of algebraic notation. Intervals that have the infinity symbol are called unbounded. In other words, they don't have an ending or they don't have a beginning, depending on which way it's written. So they're kind of unbounded. A bounded interval means that you're going to have either an open or closed endpoint. These are unbounded intervals. So if we were going to, in the past, you would maybe see this graphed like this with if this is A, we would put a dot here and shade to the right for an inequality on a number line. So if our answer was X is greater than A, or greater than or equal to A, I apologize. This is an open circle, so I need to go back and this is an open circle. Sorry, it's on the wrong one. So we would put an open circle there and shade to the right. And that's in the past how we probably saw that done. Well, now instead of an open circle there, we're going to replace that open circle with a parentheses, just a single parenthesis and shade to the right. So the open circle gets replaced with a parenthesis. And the reason we replace it with a parenthesis is because that helps us to write our interval notation. So in interval notation, this is algebraic or set notation. X is greater than A. And when you're doing this, I don't require that you put X such that. All I want in set notation is you can just write X is greater than A, and that's fine. But this is the way you write it in set notation. In interval notation, we take this parentheses, sorry, and we start with A. And the parentheses indicates that's open on that end. In other words, it stops there, but it does not include the A. And then we go to infinity, and infinity is always an open interval, so we use parentheses. So this goes to the right to positive infinity. Okay, so the same kind of thing with the open circle at A, shading to the left. That's how we used to write X is less than A without an equal. When now we just replace that open circle with a parenthesis. And then you can, once you graph these, so I suggest putting them on a number line with a graph because once you graph something like that, you have your interval notation. It's going to the left, so we know it's going to negative infinity. So we can write this goes from negative infinity up to A, not including A. Now, if we have an equal involved, this is what I was about to do a few minutes ago. If it's greater than or equal to A, we used to put a filled in dot there, not an open, but a filled in dot and shade to the right. Now with interval notation, we use a bracket. Instead of a closed dot and shade to the right, we use a bracket. So that bracket indicates that we are equal to A or greater than A, greater than or equal to A. And the interval notation would be bracket A to positive infinity with a parentheses always on infinity. So this A would have a bracket on it because there's an equal sign, whereas this one up here has a parenthesis because there's not an equal sign. So that would be the same thing with this one. If it was less than or equal to A, instead of putting a dot here, we put a bracket and we shade to the left. So this is going to negative infinity. So we would write the interval notation as negative infinity to A. And the reason that we write it like that is we want to write this least to greatest, smallest to largest. And if your solution happens to be all real numbers, then we would just write in interval notation negative infinity to positive infinity, and the whole number line would be shaded. So those are just some examples that we get when we have just single inequalities and we get either unbounded interval toward positive infinity or toward negative infinity. So let's just graph and write this, write an inequality. So we want to write our inequality in set notation here. But if you will notice, you can take the interval notation here and go straight to your number line. So this tells me that I have a 5 here with a bracket, and everything to the left will be part of that solution because it's going to negative infinity. So I would shade everything to the left. And to write that in algebraic notation, we would write x or n or whatever you want to use is less than or equal to 5. And I would know that it was less than or equal because it's shaded to the left, which means less than, and the bracket indicates that it's or equal. Now this one goes from -2. So I would put a parenthesis instead of a bracket there, and I would shade to positive infinity. So interval notation's -2 to infinity. So that means that we are greater than 2. Not equal, but greater. So we would say x is greater than -2 there. And we know we don't have an equal sign because we have a parenthesis here and not a bracket. Keeping in mind when we're solving linear inequalities, there's a couple of things you got to remember. You can solve the equation, the inequality, just like an equation. However, if you ever multiply or divide by a negative number, then you have to switch your inequality to the reverse in the reverse way. So for instance, if I had negative x is greater than or equal to -1, I would have to finish that by dividing by -1. And as soon as I divided by that negative, I know that I've got to switch my inequality to the opposite direction. That goes for if I were multiplying by a negative as well. Okay. So let's just solve a couple of these equations here. So I have my first inequality. I want to solve this for x. So I know I want to get x by itself. And when I'm doing inequalities, I like to leave my variable on the left because if the variable is on the left, then you know the direction on the number line is going to be in the same direction as your inequality. So you just got to do your inequality correctly. So if I subtract 2 from both sides, I'm trying to get x by itself. That goes to 0. I subtracted it. So I just have -5x left here. And then I'm going to divide by -5. But since I'm dividing by a negative, I've got to switch that inequality. So I end up with x on the left because these divide out to 1. X is greater than or equal to -1 because I divided by a negative, which means I've got to reverse my inequality sign. That's only when you multiply or divide by a negative, not just multiplying or dividing in general. And then it says to write it in set notation and graph it. So I'm going to graph it first because it's real easy to go from the graph to your interval notation. So I've got -1 here, and greater than or equal means I'm going to put a bracket that points to the right, and then I'm going to shade to the right, and that's going to positive infinity. So now I know I can write my interval notation as -1 to infinity. Any questions about that? Just a simple inequality, but just a couple of things we talked about, the interval notation, using the bracket for an equal, always use a parentheses on infinity, and then switching the sign if you multiply or divide by a negative through the inequality. It doesn't matter if I'm subtracting or adding, that doesn't affect the inequality, only multiplying or dividing by a negative. So we'll do one more of these and then we'll talk about some compound inequalities. This is one where I'm going to use my method of, I want to get rid of my fractions here. So in order to do that, in order to remove the fractions, remember I find my least common denominator, which is going to be 6, and I multiply everything in the equation by 6. So 6 times 1/2 x, 6 times 1/3, 6 times 1/3 x, 6 times 1. So I've just basically distributed that 6, and now I'm going to simplify everything. So this is 6 divided by 2, 3x. 6 divided by 3 is 2. 6 divided by 3 is 2x. 6 times 1 is just 6. Now, because this is an inequality, I'm going to move my variable term to the left. I want it on the left-hand side of the inequality. And I'm going to move my number. So I'm going to do this all in one step here. I'm going to get my number without a variable to the right. Just saves one step of work here. So this one gives me 0 and this one gives me 0. So I move my variable term to the left, my non-variable term to the right. So 3 minus 2 is 1. So that's just 1x or x. And then less than or equal to 4. So when I put this on a number line, I just go to -4 and it's less than. So I'm going to point my less than or equal. So I'm going to point my bracket to the left and shade to the left. And then if I wanted to write that in interval notation from left to right, I have negative infinity to -4. Any questions on either one of those problems? Okay, so what I want you, okay. Why -4 on the graph? I don't know. Thank you. I didn't get -4, did I? See, at least I know y'all are paying attention. You caught me in an error. I don't know why I put -4 there. It clearly was +4. Thank you. I didn't do that on purpose, but every now and then I will do it on purpose just to see if y'all are paying attention. But that was my mistake that time. Thank you. It's +4. 6 minus 2. It was correct here. I don't know why I put that on the just getting my mind on something else, I guess. All right, so for right now, I'm going to take a minute and I'm going to call roll and make sure that everybody that says they're here are actually here. So if you'll just type here in the chat bar there, I will see that you're here. Um, okay, everybody. Is that everybody that's here? Thanks. Okay, so when we have compound inequalities, we're going to have these compound inequalities are going to be connected with an and or an or. And so you're going to get some bounded intervals or you're going to get a union of two unbounded. So ands are always going to give you intersections. If you have an and, that's going to indicate that you're going to get the intersection of the two sets. And the little upside down U stands for intersection. So and is always going to give you an intersection. Let's see if I can spell, of two sets. Or is always going to give you a union of two sets. And hopefully when we work a couple of problems, you'll see. So immediately when I see or, I know I'm going to put the two solution sets together or get the union of the two sets. So what I'm going to do is solve the two inequalities separately and then put them on the same number line and get one interval notation solution. So I'm going to solve this one. I'm going to subtract 4 from both sides. That's going to give me negative 3x is less than negative 6. And then when I divide by negative 3, I'm going to remember to switch my sign because I'm dividing by a negative. And I'm going to get x is greater than 2. So I'm going to go ahead and solve the other side. 3x minus 6 is less than or equal to negative 6. I'm going to add 6 to both sides. And I'm going to get 0. So divide by 3. I get x is less than or equal to 0. I'm going to union those two sets on the same number line, and then I'm going to write it in interval notation. So the first one tells me that I've got 2 bracket and everything greater than 2. And the second one tells me that I've got a 0. Oh, that's a parenthesis. Excuse me. Let me fix that. I think I was drawing a parenthesis. No equal there, so I don't want a bracket. I want a parenthesis. Shade to the right. And then on the second one, I do have a bracket at 0. And I'm not real picky about you putting a bunch of numbers on your number line. You can just show me the numbers that are involved. So 0 and everything to the left. So how in the world would we write this in interval notation? Well, you just write two different sets, two different interval notations, and put a union in between them. So this one tells me I'm going from negative infinity to 0 with a bracket on 0. And then I just put a union of 2 to positive infinity. So I have two separate answers that I'm putting together on the same number line. So my interval notation just has a U in between them to indicate that I union those two sets of answers. So the solution to that compound inequality could be anywhere from 2 on, but not 2, or anywhere from 0 less than 0. Any of those numbers could be a solution. The only thing that's not a solution is what's in between the 0 up to the 2. So you just use a union sign when you have an or. Any questions on that one? Now, I'm going to add a slide in here because I want to show you something. If you worked your problem out and you did everything correctly, so this is an if. So if this happened, if you had two inequalities and they were both, let's say you had x is greater than -2 or x is greater than 3. We want to know which one of those answers, because it's not going to be both of them. They're going in the same direction. So I'm going to graph the first one is greater than -2. So I would use a parentheses and I would shade to the right. Then the second one I'm going to do in red. It also says that we have x is greater than 3. If you put those two sets together, you're going to shade all of this one. And notice that it covers up the other one. So since you're putting the two sets together, your answer is not both of those, but just that one. Because the one that's greater than -2 covers up the one that's greater than 3. So you would only write this for your answer. So you would write -2 to infinity. Excuse me. -2 to infinity. And you wouldn't write the x is greater than 3 because it's already taken care of in that solution. I hope that makes sense to you. I just wanted to show you an if then. If they go in the same direction, then you pick the one that covers up the other one for your solution. Okay, this is a compound inequality that involves and. I'm going to show you 2 ways you can work this problem. I guess with this one, you're just going to have to work it out. Sometimes they give you an and as a compound inequality, and I'll do one and show you how that works. So for this one, we have an and, so we know in the end of the problem, we're going to get the intersection between these two. So I'm going to solve this one by multiplying through. I'm going to multiply through by the denominator here, which is -2. Keeping in mind that I'm multiplying by a negative, so I'm going to have to switch that sign. So I'm going to multiply by -2. I'm going to have to switch the sign because I'm multiplying by a negative. So these are going to cancel out to 1. So that's going to leave me with 2x minus 5 is greater than -4. So x is greater than 1/2. This side I'm going to multiply by 3. Now I'm not going to write this out, but when I multiply by 3, it just cancels the 3 out over here. So I'm going to have 2x plus 1. And when I multiply 3 times 0, I'm still going to get 0. So I'm going to subtract 1. And I'm going to get 2x is greater than -1. So x is greater than -1/2. I want to union those two sets together. So I want to put those on the same number line, and then I'm going to shade only where the intersecting part of that graph is. So I have 1/2 -1/2 1/2. Greater than, this one's greater than -1/2. So that means I'm going to put a parenthesis here and I'm going to shade to the right. I'm sorry, that was this one, greater than -1/2. And then the first one was greater than 1/2. So I'm going to put a parenthesis there. Let me do it in a different color. Put a parenthesis and shade to the right. Now I want you to look at that graph and tell me only the intersecting part. So the intersecting part would be where I have red and black. So it would be here. That would be the only part that intersects for that. So my answer would be, in interval notation, 1/2 to infinity. Because that would be the intersecting part of that solution. So when you do an and, you only can use the intersecting part for your answer. Do I have any questions on that part? So I just solved the inequalities separately, really, but the only difference is with or, you want to pick you want to pick the union. So you want to pick the one that covers the union of the two sets. If you have and, then you only want to pick the intersecting parts. Now I'm going to put a slide in here. I'm going to show you how you can solve one that's already in compound form. What in the world? So if I have something like this, if the problem doesn't say or, then it's automatically and. Okay, so if the problem doesn't say or, automatically it's an and. So anytime your problem doesn't say or, we know it's going to be an intersection. So I want to show you how, if it's already written in this compound form, you can do this. You can just solve by, you can just solve the equation this way, the inequality this way. So you can add 1, but instead of to 2 sides, you're going to add it to all 3. You're going to add it to the left, the middle, and the right. So I get -1 on the left, the 1's cancel, and I get 4 on the right. And then I'm going to divide all 3 parts by 2. So that cancels out to 1. So I have -1/2 less than or equal to x less than or equal to 2. And I can put this straight on the number line. And if -1/2 is less than or equal to x, that means x is greater than -1/2. So 1/2 is going to be my smallest, and 2 is going to be my largest. And I'm using brackets because we have equal. And only the part inside is what's going to be intersecting. So basically, if it's in compound form, it's going to automatically give you your boundaries in between x. And it should say less than. X should be in between 2 less than signs. If it's not, then you're going to rewrite it so that it's less than. You're just going to switch all of your signs over. So that sort of gives you some of the different problems that you will come upon with and or. So remember, if it's a compound inequality and it's already in compound form, you can just solve it in that form. And then you can just put your answer in between the 2 boundaries. Now, the last thing that we go over in this absolute value inequalities, and there are certain things that are going to imply either and or. If you have a greater than symbol in an absolute value, you're going to write 2 equivalent statements, but you're going to put an or in between. So for absolute value inequalities, so any absolute value inequality, here's my little shortcut way to remember. If I have greater than or equal, I misspell greater in my mind and I put greater instead of greater. So if it's greater, then in my mind, I think greater, and I know I'm going to put an or in between my 2 statements. So if you have an absolute value inequality, remember back in the first section, we solved equations and you had to write 2 separate equations for the absolute value. And if you didn't write the 2 separate equations, you were only going to get 1 correct answer because you were going to miss half the problem by not getting 2 answers. So anytime there's absolute value, you have to write 2 equations or 2 inequalities. The only discussion in the inequalities is, do you put an and or do you put an or in between? Well, if it's greater, you put a great. If it's greater, you put an or in between. If it's less than, I misspell that as well and I write less than instead of less than. I put my misspelled part in quotes. So I know if there's a less than, I'm going to put an and in between. So I use a little misspelling to do that. Now I've got 2 simple inequalities here. And I know I've got to write 2 inequalities. So first you want to isolate the absolute value. just like before. Then write two inequalities. Determine whether you put and or in between. Okay, determine if it's and and then solve. So step one, get the absolute value by itself. Two, write two inequalities. Three, determine if it's and and I just showed you how to do that, and then solve. So absolute value is already by itself, so I'm going to write my two inequalities. I've got x minus 3x minus 1 is less than 2. 3x minus 1, switch the sign here, greater than -2. So it's just like the absolute value where we wrote 1 was equal to 2 and 1 was equal to -2. Well, here we're going to write less than 2 and switch the inequality and change the sign. So let's write this up here in step number 2. Switch the signs on the second inequality. I'm just abbreviating here. So in step number 2, make sure you switch the sign. Switch the inequality, switch the sign on your right-hand side number there. And since it was less than, remember I'm going to misspell that, less than, put an and in between. So that means I'm looking for the intersection of those two sets. So I'm going to solve. I've got 3x is greater than 3. X is greater than 1. And X is greater than. I'm sorry, where did that greater than come from? I don't switch that. I think my brain got fried or something. I don't know. There was no reason to switch that sign is what I'm saying. I added 1 to both sides and then I divided by 3. So I shouldn't have switched that sign. I apologize for that. So now we have greater than -1/3. So let's put that on a number line. We've got less than 1, so I'm going to put a bracket there. I meant not a bracket, I'm sorry, a parenthesis. Told y'all I need to quit today, don't I? Parentheses, because there's no equal, and I'm going to go less than 1. Then -1/3, parentheses, because there's no equal, and I'm going to shade to the right. Now for my final solution, I'll have and, so I'm looking for the intersection. So the intersection is what is in between the two.
Where did you get the negative for the 1/3?
Right here.
Right where?
When you switch your signs there in step number 2, you got to switch the inequality and switch the sign of this number, just like when we did the equations. So you want to switch
Oh, okay.
the sign, make it a -2. So then when I added 1, I had a -1/3 there on the right.
Okay. Yes,
Okay.
ma'am. Thank you.
Yeah. So switching the sign in step number 2, right here, switch the sign on the inequality and the number there. So the intersection would be what's in between those two solutions. So I think
Microphone isn't working. No one can hear you. Are you covering your microphone?
no, I'm not. Let me mute. Can you hear me now?
I can hear you now.
Okay, so how long has it been since you couldn't hear me?
This is
When you asked me the question?
yes, ma'am. You like just started talking about something else and then you kind of cut out.
Okay, I've got you. All right, so here's what I was planning to do is I'm going to erase these steps over here and I'm going to rewrite them for you neater as I work through this next problem. Okay, so step number 1 was to,
Miss Rachel,
yes,
no one can see your screen either.
that's lovely. Let me fix that. Thank you for being my eyes.
Yes, ma'am.
Okay. Here we go. Step number 1, I want to isolate the absolute value. So that means I need to get this absolute value by itself. I'll try to go quickly so you guys can go. So the first thing I need to do is I need to subtract 6 from both sides. I'm trying to get the absolute value by itself. So I'm subtracting the 6 to make that go to 0. Now I'm going to divide, because this is multiplying, I'm going to divide by 3, and that's going to cancel out to 1. So then I have absolute value of x minus 2 is greater than or equal to 1. So I got step number 1 done. Step number 2, write 2 inequalities and make sure to switch the signs. So I have x minus 2 is greater than or equal to 1. It's greater, so I'm going to put what in between? I'm going to put 4. X minus 2, switch the signs, -1. So I wrote those, and step number 3 I've already done. I determined the and or. Which one goes in between. And then the last step is just to solve, and then you'll graph your inequality. So adding 2 to both sides, I get x is greater than or equal to 3, or x is less than or equal to 1. This is an or, so when I get my solution, I'm going to put a bracket because I have an equal, and I'm going to shade to the right. So that would be the first one. X is greater than or equal to 3. And then x is less than or equal to -1. So I would put negative infinity to 1 and I would union that with 3 to infinity. So there's one of them where you have a less than, so you put and get the intersection, and there's one where you have greater than, so you put or, get the union of the two sets. And if I went too fast through any of this, go back through the 1.8 video and you can pause it, go back and look at anything that you need. So I'll put those videos for your benefit in case you need to go, um, in case you need to go back and look over some of this. But that's all I have for today. And remember, the next time we meet, we'll be reviewing. So do your review that I posted in the module. There should be a printable review that you can do and bring me questions. And I also think I put you a practice in Math Lab. So you can do that one. You can do either or. Um, yes, it is. Thank you. The infinity is supposed to be positive. I'm sorry. I told y'all I was having a bad day, so I have those every now and then. Thank you. That infinity is supposed to be positive. Thank you very much. Every now and then I have a bad day. Shouldn't be on this day, huh? Okay, so again, in the modules, there should be a review for chapter 1 that you could print, and the answers should be there for you as well. And then there's also, I believe, a practice in Math Lab that you can do. So just bring me the questions, bring me any questions that you might have, and we will go over those questions on Thursday. If anybody wants to stay and you have any